There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, quatactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium.
This is our pH. That's the saltpeter,
Plastic cup,
copper mesh,
and plastic wrap.
plastic. Okay, so the first step is to put the copper mesh in the cup.
Make it lie flat. And we add 80 milliliters
Pre-measured.
already measured out, of pH lowering solution.
We're pouring that in.
And we need to add 8 grams of saltpeter.
Exactly 8 grams.
And swirl.
Swirling.
Make sure to mix them.
Okay, now we are going to lightly cover it with plastic wrap and let sit for 12 hours.
This is the equilibrium lab.
Equilibrium.
So
Okay.
first,
Okay, that's first.
your see-through plastic.
So we're going to pour 2 inches into the see-through plastic cup.
And this is copper sulfate.
Copper sulfate made in our other part. So next we will add 120 milliliters of water into
our
a soda bottle,
which we've
which
replaced these with
with
soda
a
bottles.
Erlenmeyer flask.
Pre-measured 120 milliliters. 100
And then the other 20.
and 20.
And next we need to add 2 tablespoons of baking soda to this one in order to create one of our reactants. And the other one we will just put in there. So we'll mix a little bit, so we'll add there.
Alright.
Now swirl the concoction.
And then while we're doing that, we can add 3 inches of vinegar into the other soda bottle.
Okay, so now we're going to add 3 or 4 drops of the baking soda solution into the copper sulfate using our copper. Perfect. Okay, 1, 2, 3. And it should form a precipitate at the bottom. So there's the precipitate forming at the bottom, as you can see right in there. The white cloudy precipitate. Now we're going to reverse it and create our equilibrium system. Next we will add
Add a few more drops of baking soda.
increase the volume of the precipitate.
There we go.
It's getting thicker at the bottom.
Now we're going to add a couple more drops of vinegar.
We will now reverse our precipitate, adding the vinegar, a few drops of vinegar.
And now we can see that the precipitate is mixing with the rest of the liquid and is slowly disappearing. But it's still a little at the bottom, so we'll keep on adding some more vinegar. And swirling. And now it is all gone.
We are able to eliminate our precipitate by adding vinegar is because vinegar is an acid, acidic acid, and when an acid reacts with a base, they tend to sort of neutralize each other. So we have our copper sulfate and we add the baking soda, which is the base, sodium bicarbonate, and we create copper bicarbonate as the precipitate in an aqueous solution of sodium sulfate. And so the precipitate is the base, basically, because it's got the baking soda in it. So when we add the vinegar, which is acetic acid, it will neutralize the base and release CO2 because it's a decomposition reaction, which will virtually neutralize the baking soda's effects, and we will be left with our original product, copper sulfate.
So one example that we have is if you take a bottle of soda, which has carbonated like water or juice inside of it, and you release it, you can hear the carbonation escape, and that's because there's a balanced system between the gas pressure in the top of the bottle and the carbonation in the water that doesn't allow for any more carbonation to come up out of the water, and that's why your drink stays fizzy. But if you, say, poured out half the bottle and then closed it up again, more carbon from inside the liquid would come up and replace the gas pressure and the volume that was lost to the spilled drink. So until the carbonation replaces the gas, more carbonation will keep coming from the liquid. But then once that system is balanced, then no more carbonation will move. And the same is in our demonstration. If you like just leave it open for a long time, the soda will go flat, and that's the same thing as like diluting our demonstration.
There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercurium, molybdenum, magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium.